Imagine stepping into a brand new career, fully skilled and confident, without ever leaving your living room. Sounds like science fiction? Well, welcome to the reality of virtual reality job training, a revolution that's reshaping how we learn, practice, and master professions. Today, we delve deep into a groundbreaking concept, a comprehensive VR platform designed to provide immersive, hands-on job training across diverse industries like healthcare, construction, manufacturing, technology, and even customer service. Forget dusty textbooks and passive video lectures. This is about experiencing, about building real-world skills in a perfectly safe, endlessly repeatable simulated environment. So what exactly is virtual reality job training? At its core, it's the use of VR technology, typically a headset and controllers, to create computer-generated environments that replicate real-world workplaces and scenarios. Users are fully immersed in these virtual spaces, able to interact with objects, tools, machinery, and even virtual colleagues or patients, just as they would in reality. This isn't just about visualization. It's about kinesthetic learning by doing. You're not just watching someone perform surgery, you're holding the virtual scalpel. You're not just reading about operating a crane. You're sitting in the virtual cab, manipulating the controls, feeling the simulated weight. This platform acts as a versatile digital training ground, offering a library of modules covering countless procedures, protocols, and skills across various fields. Why is this shift towards VR training happening now? Several factors converge. VR hardware is becoming more affordable, powerful, and user-friendly. The software development tools are maturing, allowing for the creation of highly realistic and interactive simulations. And critically, businesses and educators are recognizing the profound limitations of traditional training methods, especially for complex, high-stakes, or hands-on roles. The demand for skilled labor is high and efficient. Effective training is paramount. VR offers a solution. Let's explore the core benefits in detail. Benefit 1. Unparalleled immersion and engagement. This is VR superpower. By hijacking our senses, particularly sight and sound, VR creates a sense of presence, making the user feel genuinely there in the simulated environment. This deep immersion commands attention. Distractions from the real world fade away. Compare this to sitting in a classroom where minds can easily wander, or watching a training video passively. In VR, you are an active participant. This active engagement significantly boosts knowledge retention. Studies consistently show than passive methods. You're not just memorizing steps, you're building muscle memory, understanding spatial relationships, and internalizing complex processes through direct interaction. Imagine a trainee learning to assemble a complex piece of machinery. In VR, they can pick up virtual parts, rotate them, see how they fit together, follow guided steps, and even make mistakes without damaging expensive equipment. This level of engagement accelerates the learning curve dramatically. Benefit 2. Enhanced safety. This is arguably one of the most compelling advantages, especially in high-risk industries like construction, healthcare, manufacturing. VR eliminates these physical risks entirely. A medical student can practice complex surgical procedures dozens of times, making errors and learning from them without any danger. To a real patient, imagine rehearsing emergency response protocols in a simulated hospital ward during a mass casualty event. The chaos, the pressure, the decision-making, all honed in a consequence-free virtual setting. In construction, trainees can learn to operate heavy machinery like excavators or cranes. They can practice working at heights, identifying hazards on a virtual job site, or responding to simulated emergencies like fires or structural collapses, all without the risk of injury or costly damage to real equipment. Firefighters can train for complex scenarios like navigating smoke-filled buildings, performing search and rescue, or handling hazardous materials spills, scenarios that are difficult, expensive, and dangerous to replicate consistently in real life. This ability to practice rare but critical emergency procedures repeatedly builds competence and ensures that when a real crisis occurs, personnel are prepared. Benefit 3. Cost effectiveness. While initial setup costs for VR hardware and software development exist, the long-term return on investment can be substantial. Consider the costs associated with traditional training, travel and accommodation for trainees and instructors, especially for centralized training centers, physical materials and consumables used during training, think medical supplies, construction materials, manufacturing components. These can be very expensive and are often single-use. Wear and tear on expensive machinery and equipment used for training. Taking a critical piece of equipment offline for training purposes also incurs opportunity costs. Instructor time and resources. Highly skilled instructors are valuable, and their time is often split between training sessions and their primary duties. Costs associated with errors made during training, potential damage, rework, or even injury. VR training mitigates many of these costs. Training can happen anywhere, eliminating travel. Virtual materials are infinitely reusable. There's no wear and tear on virtual equipment. Once a module is developed, it can train countless users with minimal ongoing instructor supervision needed for the core practice component. Errors are learning opportunities, not costly incidents. Companies using VR training often report significant reductions in overall training time and costs, sometimes by as much as 50% or more, alongside improvements in trainee performance and confidence. Benefit 4. Accessibility and scalability. A VR training platform allows learning to happen anytime, anywhere. All a user needs is a compatible headset and internet access. This democratizes access to high-quality training, breaking down geographical barriers. A trainee in a remote location can access the same sophisticated surgical simulation as someone in a major urban hospital training center. Furthermore, VR training is highly scalable. Once a training module is created, it can be deployed simultaneously to hundreds or thousands of users across different locations. This is impossible with traditional hands-on training, which is often limited by the availability of physical equipment, space, and instructors. Companies can rapidly onboard new hires or upskill existing employees consistently and efficiently, regardless of scale. Training can also be done asynchronously, allowing employees to learn at their own pace and fit training around their work schedules. Benefit 5. Standardization and consistency. Human instructors, while invaluable, can sometimes introduce variability into training delivery. Different instructors might emphasize different aspects, explain things differently, or have varying levels of expertise. VR training ensures that every single user receives the exact same instruction, follows the same procedures, and is evaluated against the same objective criteria within the simulation. This standardization is crucial for quality control and compliance, especially in regulated industries. Companies can be confident that all employees have been trained to the same high standard, reducing variability in performance and ensuring adherence to best practices and safety protocols. Benefit 6. Rich data and analytics. VR training platforms aren't just about delivery. They are powerful data collection tools. Every action a user takes within the simulation can be tracked, measured, and analyzed. This includes task completion times, accuracy rates, procedural steps followed or missed, decisions made, even potentially biometric data, like gaze tracking where the user is looking, or stress levels if sensors are integrated. This granular data provides objective insights into trainee performance that are often difficult to capture through traditional observation. Instructors and managers can identify specific areas where individuals or groups are struggling, pinpoint knowledge gaps, and tailor feedback or further training accordingly. The platform can generate detailed reports. This data-driven approach allows for continuous improvement of both the training programs and individual employee skills. Benefit 7. Reduced error rates in the real world. Because VR allows for extensive, risk-free practice, trainees can achieve a higher level of proficiency and confidence before ever performing tasks in the real world. Practice makes perfect, and VR provides the ideal environment for that practice by identifying and correcting mistakes. In the simulation, trainees are less likely to repeat those errors on the job, where consequences can range from minor inefficiencies to catastrophic failures. This translates to improved quality, increased productivity, enhanced safety outcomes, and reduced operational costs. Benefit 8. Increased confidence and competence starting a new job or learning. A complex new skill can be intimidating. VR provides a psychological safety net. Trainees can experiment, fail, and try again without fear of judgment or negative real-world repercussions. This freedom to explore and master skills at their own pace builds genuine confidence. When they finally encounter the situation in reality, they feel prepared and capable, having already navigated it successfully multiple times. In the virtual world, this confidence boost is invaluable for job satisfaction, performance, and retention. Benefit 9. Training soft skills. Job training isn't just about technical procedures, it's also about interpersonal interactions, communication, empathy, conflict resolution, teamwork. VR is surprisingly effective for honing these soft skills. Platform can simulate realistic social scenarios with virtual humans avatars, powered by AI, or even controlled by other trainees or instructors. Imagine a retail employee practicing how to handle an angry customer, a manager learning to give difficult feedback, or a doctor practicing delivering bad news with empathy. These simulations allow users to rehearse responses, observe virtual character reactions, and receive feedback on their communication style and effectiveness in a safe space. This is incredibly difficult to achieve effectively through traditional role-playing. Now let's dive deeper into specific industry applications. Allow medical students and surgeons to practice complex procedures like laparoscopic or robotic surgery, improving dexterity and reducing errors before operating on real patients. VR enables detailed anatomical exploration, letting students virtually dissect bodies or view complex organs from any angle. Nursing skills, like inserting raw meat or managing patient care plans, can be practiced repeatedly. Empathy training modules help clinicians understand patient perspectives by literally putting them in the patient's shoes, experiencing conditions like vision impairment or dementia virtually. Emergency response drills, triage scenarios, and teamwork coordination during crises can be realistically simulated and practiced by entire teams, improving preparedness for real emergencies. The data capture capabilities allow instructors to precisely measure surgical precision, diagnostic accuracy, or adherence to patient safety protocols, providing objective feedback. Construction. Safety is paramount in construction, and VR provides a powerful tool for safety training. Workers can learn to identify potential hazards on a virtual site, like unsecured scaffolding, tripping hazards, or unsafe electrical wiring without being exposed to actual danger. Training for working at heights, including proper use of fall arrest systems, can be realistically simulated. Operating heavy machinery, like cranes, excavators, bulldozers, and forklifts, can be practiced extensively. Developing control skills and spatial awareness before handling multi-million-dollar equipment. Complex assembly processes or installation procedures can be visualized and practiced step by step. Virtual site walkthroughs allow project managers and teams to review plans and identify potential clashes or issues before construction even begins. Manufacturing. Similar to construction, VR enhances safety and operational efficiency. Trainees can learn complex assembly line tasks, practice quality control inspection, and master equipment operation and maintenance procedures in a virtual factory environment. Lockout-tagout procedures, crucial for preventing accidental machine startups during maintenance, can be drilled repeatedly. Lean manufacturing principles and workflow optimization can be visualized and experimented with. Training on new equipment or processes can be rolled out quickly and consistently across multiple plants using standardized VR modules. Technology and IT, while perhaps less obvious, VR offers valuable training applications here too. Imagine practicing complex data center operations like installing servers or managing cabling. In a virtual replica, Network configuration and troubleshooting scenarios can be simulated. Cybersecurity training can become more engaging through immersive simulations of phishing attacks or incident response procedures, while coding itself might remain screen-based. Understanding system architecture or collaborating on complex projects could potentially benefit from immersive visualization tools. Public safety, law enforcement, firefighting, MZAs, VR allows first responders to train for high-stress, unpredictable situations safely and repeatedly. Police officers can practice de-escalation techniques with virtual suspects exhibiting varied behaviors, use of force, decision-making, and active shooter response protocols. Firefighters, as mentioned, can train for various fire scenarios, search and rescue in zero visibility, and hazardous materials incidents. EMS personnel can practice patient assessment triage in mass casualty incidents and coordinating care with other responders in complex virtual environments. The ability to recreate specific local environments like schools or public buildings adds further realism. Retail and customer service. Beyond technical skills, VR shines in soft skills training. Employees can practice handling difficult customer interactions, managing checkout scenarios, learning store layouts, and mastering product knowledge in simulated store environments. Onboarding new staff can be accelerated by familiarizing them with the workspace and common tasks before they hit the shop floor. Training on empathy and effective communication can lead to improved customer satisfaction and loyalty. Aviation and aerospace. Flight simulators are the original VR trainers. Modern VR extends this concept to aircraft maintenance training, where technicians can practice complex repair procedures on virtual engines or components. Cabin crew can rehearse emergency evacuation procedures, firefighting, and passenger assistance in realistic virtual cabins. Ground crew can practice aircraft marshalling or baggage handling procedures. Energy sector. Training for hazardous environments like oil rigs or power plants is ideal for VR. Workers can learn safety protocols, emergency shutdown procedures and equipment, maintenance without setting foot on a dangerous site. Training for renewable energy installations, like wind turbine maintenance, often involving working at heights, can be made safer and more accessible through VR. So, how does a platform like this actually work? From the user's perspective, it starts with putting on a VR headset, devices like the MetaQuest, HTC Vive, Pico, or others, and holding motion controllers that track hand movements. They launch the training application and enter a virtual lobby or menu system. Here, they can browse a library of available training modules relevant to their job role or industry. Selecting a module transports them into the specific simulated environment: a hospital room, a construction site, a factory floor, a retail store. Within the simulation, they can look around freely, move using various locomotion methods like teleporting or smooth walking, and interact with objects using their controllers, picking up tools, pushing buttons, opening doors, manipulating machinery controls. The training modules often include guided instruction, perhaps from a virtual instructor, or through on-screen prompts and highlighted objects. They might follow a specific sequence of steps, respond to simulated events or emergencies, or practice decision-making. Feedback is often immediate. If a user makes a mistake, the simulation might pause, provide corrective guidance, or show the consequences of the error, e.g., a virtual machine malfunction. Upon completion, the platform typically provides a performance summary highlighting successes and areas needing improvement. Behind the scenes, the platform relies on sophisticated software. This includes a powerful graphics engine like Unreal Engine or Unity to render the realistic virtual environments, a physics engine to simulate object interactions realistically, and the specific logic for each training module. A learning management system, LMS backend, often manages user profiles, tracks progress, collects performance data, and generates reports for administrators and instructors. Content creation involves 3D modeling, programming interaction logic, and instructional design expertise to ensure the simulations are both engaging and educationally sound. While the benefits are immense, it's important to acknowledge potential challenges and limitations. Hardware costs, although decreasing, the cost of VR headsets and potentially powerful PCs needed to run high-fidelity simulations can still be a barrier for some individuals or smaller businesses. Standalone headsets like the Quest series have significantly lowered this barrier, however. Content development, creating high-quality, realistic, and effective VR training modules requires specialized skills in 3D design, programming, and instructional design. This can be time-consuming and expensive, though reusable assets and development platforms are streamlining this process. Cyber sickness. Some users may experience motion sickness or discomfort. Cyber sickness in VR, particularly with experiences involving artificial movement. Developers are continuously improving hardware, higher refresh rates, wider fields of view, and software techniques like stable locomotion options to minimize this issue, and most users adapt over time. Integration. Integrating VR training effectively into existing curricula and workflows requires careful planning and change management within organizations. It should complement, not necessarily replace, all traditional methods. Simulation fidelity. While impressive simulations may not perfectly replicate every nuance of the real world, particularly subtle sensory feedback like touch or smell, though haptic, are improving. Ensuring the simulation is realistic enough for effective skill transfer is an ongoing challenge. Despite these challenges, the trajectory is clear. The future of VR job training looks incredibly bright. We can expect increasingly realistic graphics and physics, pushing immersion even further. Advanced haptic feedback devices, gloves, vests, or controllers that simulate touch, texture, resistance, and impact will add another layer of realism, crucial for tasks requiring fine motor skills or tactile feedback. Artificial intelligence will play a larger role, creating more dynamic and adaptive training scenarios. AI-powered virtual characters will exhibit more realistic behaviors and conversations, enhancing soft skills training. AI will also personalize learning paths, adjusting difficulty based on user performance and providing highly tailored feedback. Multi-user VR training will become more common, allowing teams to practice collaborative tasks and communication in shared virtual spaces, regardless of their physical location. Integration with augmented reality (AR) could create blended learning experiences, overlaying digital information or guidance onto the real world for on-the-job support. After initial VR training, we'll see wider adoption across even more industries as the technology proves its value and becomes more accessible. Education, hospitality, logistics, sports. The potential applications are virtually limitless. In conclusion, practical tool transforming workforce development today. The ability to create immersive, engaging, safe, and cost-effective training simulations offers unprecedented advantages over traditional methods for countless professions. Platforms like the one described, offering diverse modules for healthcare, construction, tech, and beyond, empower individuals to master complex skills and build confidence from the comfort and safety of their own homes. For companies, it represents a way to drastically reduce training costs, improve safety, standardize learning, gain deep performance insights, and ultimately build a more skilled, competent, and adaptable workforce. The promise of mastering almost any career from your living room is rapidly becoming a reality. Thanks to the transformative power of virtual reality, the future of work is learning, and VR is leading the way.